everyone, my name is Smriti, and today we'll be walking through the Week 7 CSM worksheet, problem number 4. Today we'll be looking at stacks and queues and how they can affect a tree traversal problem. And so here we have some pseudocode, or actually not pseudocode, some actual code that has a method called tree traversal on erase mode. It's tree traversal where we have a while loop and a fringe, and basically we want to see what Java would print out if this function is to be run. So here we have in part A, we're inputting a queue into the function, and in part B, we're inputting a stack. And so, yeah, our goal is to look at this tree on example tree on the left, and if that was inputted, see what Java would actually display. So before we get started with the actual problem, we should probably look at for part A, what is a queue and how does that affect the traversal? So if you go down here, a queue is a data structure which is first in, first out. And so it works like a normal list where the first element that you insert is the first element that will come out. And so if I were to insert this way and I were to pop out that way, the element that I first insert will be the first one to come out. So I would insert 1, 2, 3, 4, 5, 6. And so 1 will be the first element that is printed out. And a queue works like any normal list or any normal line. So if you were to wait in line at the movies, the first person in line will be the first person to buy a ticket. And so you can think of a queue as a normal queue in real life. And so that's how they work. Cool. So now let's move on to this tree traversal. I've copied over the code here. So we see that in the beginning, we're adding the root to the fringe. And while the fringe is not empty, we are popping off a node from the fringe and printing its value. And then we're moving on to traversing the left and the right side of the node. And so if the left side is not null, we're adding that to our fringe. And if our right side is not null, we're adding that to our fringe. And so in this case, our fringe is a queue since we pass in a queue right here. And so let's visually represent this because our end goal is to see what this program is going to print out. And so I'm going to draw out a queue right now. Cool. And so let's just denote this is the front and this is the end of the queue. Cool. And so let's basically walk through this code for this example tree right here. The first thing that we want to do is add the root. So we're going to add the root that I just highlighted to our queue. And so at the front, we'll be adding A1. Cool. And so the fringe is not empty. So we're going to enter this while loop. We're going to pop off the first element in our queue. And so that's going to be 1. So we're printing out 1. And then we're going to remove it from our queue. And then we're going to look at the left of 1, which is this 2. And since it's not null, we're going to add that to our fringe. So we're adding 2. I'll actually use a different color to show the different levels that we're doing. So here, this can be blue. So I'm going to add 2 to my queue. And then it's going to look at the right side of this first node that we're exploring right now, which is 1. So node.right is going to be 7, which I'll also highlight. And so 7 will be added to the queue. Cool. And so we've gone through one iteration of this while loop. So we're going to go back to the top and we're going to remove from the front of our queue. And so if we remove from the front, since 1 is gone, that'll be 2. And so we're going to print out node.value, which is 2. So we can remove 2 and write down 2 here. Cool. So now we're looking at this side of the tree. We're going to look at the left leaf on this 2 nodes. So the node.left is 5. So I'm going to do this in a different color. We're going to add that to the queue. And then its right is not null. It actually has a right side too. So its left was 5 and its right is 9. So I'm going to add 9 to the queue. Cool. And so now what I can do is go back to the top of my while loop and remove from the fringe again. So now I'm going to remove 7 from the fringe because that's the next thing I see on there. So I'm going to print out 7 here. Let's go back to this blue color. Cool. And so now I'm going to basically go through this entire thing again. And so now I have removed 7 from my queue. I'm going to explore the left side of 7. We see here that 7 has no left side, it's null, so I'm not going to do anything. I'm going to look at its right child, and its right child actually has a value 3, so I'm going to add 3 to my queue. Let's see if we can see this color. Yeah, we can. Cool. So cool. Yeah, I've looked at both children of 7, and then I'm going to go back to the beginning of my while loop, remove a node from the fringe, but the next node in the fringe is actually 5, so I'm going to remove 5. I'm going to print out the value of 5, which I put an arrow there, so I'm going to print out 5. And then now I'm here. Does 5 have any children? So I'm going to look at the left side, it's null, and the right side is null, so I don't really add anything. These are both null. So I don't add anything to my fringe. Cool, now I can go back up to do another loop of this while loop. So now I'm going to remove 9 from the fringe and print out its value. Does 9 have any children? No, these are both null. And so I am not going to add anything to the fringe on that instance. Then I'm going to go to 3. And so I'm going to print 3. Change the color here. Now I'm going to look at the left child of 3. Oh, it actually has a left child. It has 4. So I'm going to add that to my fringe. It doesn't have a right child. That's null. So I'm not going to add anything there. And then cool. So then I'm going to go back up to the top of my while loop, and I see I have one more item left on the fringe. That is, I actually probably shouldn't have written this 4 in green since it is a different level. I'm going to change the color there. Let's go purple. Cool. So I'm going to go back up to the top, remove 4 from my fringe, print out the value 4. 4 does not have a left or a right child, and so I will not be adding anything to this fringe. And yeah, we can, since the fringe is now empty, I have removed all of these elements from the fringe. We can say that we can end this while loop, and this is what we're going to output. So this is what Java would display for part A of this problem. Cool. Yeah, if you have any questions on how we came up with that, definitely reach out to your mentor. But if not, let's move on to part B, which is using a stack, which is another data structure. So as I did with queues, before we jump into part B of this problem, I do want to look at how we traverse stacks. So stacks are different from queues in that they are last in, first out. So I should write stack here. This means that a stack, if you were to represent it like this, the last element that you add will be the first element to come out. And so if I were to represent a stack with 1, 2, 3, and 4, I add, and then I also remove. So 4 is the last element I inserted, and 4 would be the first element to come out. The way I think of stacks in real life is kind of like a stack of papers. So if you were to stack a bunch of papers on top of each other, the first paper that you pick up will be the last one that you put, since it's at the top of the stack. And so that's how I think about it. It works the same way as it does in real life. Cool. And so now that we know what a stack is, we can move on to how to actually traverse a tree using a stack as the preliminary data structure behind it. So I'm going to erase everything I've done here with the queue traversal so that we have a blank slate to start out with. Cool. And we're basically going to do the same thing for stacks, go through this while loop, but we'll see that our fringe is going to look a little different since it is a stack and it's last in, first out. And so we're going to get a different traversal. Cool. So a stack can be represented like this. And so let's just say that this is the top and this is my bottom. Cool. So here, what I'm going to do is add the root, which is 1, to the bottom of my stack. So I'm going to insert a 1 right here, and then I'm going to print its value, which is 1. Cool. And then I'm going to look at its left and its right children. So that is 2. Its left child is not null, so that's 2. I'm going to insert 2. And its right child is not null, it's 7, so I'm going to insert 7 into my stack. And you'll notice how I'm inserting into the stack is a little different from how I was inserting into the queue. So the elements that I'm looking at later actually end up being at the top of my stack. And so then I'm actually going to go back up to the top of my while loop, and then I'm checking if the fringe is empty, which it's not. Then I'm going to look at the first node in my stack, which is 7, and I'm going to remove that from my fringe. And so I'm going to print that view and remove 7. And then I'm going to look at 7's children, which are null and 3. So its left child is null. I'm not going to add anything to my fringe. My right child is 3. And so I'm going to add 3 to my fringe at the top. Cool. And so then I'm going to go back up, do another iteration of this while loop. The fringe is not empty. I'm going to remove 3 from my fringe and print out its value. So I'm going to cross out the 3 right there, print out its value. I'm looking at the left child of 3, which happens to be 4. Let's change the color here. I'm going to add that to my fringe. Oh no, the stack is getting a little too tight. Maybe I should make it a little bigger. Make this black. Sorry, let me just expand my stack a little. Cool. Yeah, so where was I? Oh yeah, I just added 4 to my fringe, and then I am done since it doesn't have a right child, so it's not going to add anything. I'm going to go back up. Now I'm going to remove 4 from my fringe and then print out its value. So 1734 is the current output of what would Java display. So does 4 have any children? So I'm first checking the left of 4. This is null. The right of 4 is null. So nothing is going to be printed or added to the fringe, sorry. Then I'm going to go back, do another iteration of this while loop. I'm going to remove the first item on the fringe, which is now 2, since I didn't add anything after 4. So we're here. I'm going to print out 2. Let's go back to what color that was. That was red. Cool. And so now I'm going to look at the left child of 2, which is 5. Add that to my stack. I'm going to look at the right child of 2, which is 9, and add that to my stack. And then 2 has also been removed from this. I should point that out. And then I'm going to go back up and look at the top of my stack, which is 9. So I'm going to add 9. Cool. And I also would remove that from my stack. I remove it and then print out its value. 9 does not have any left or right children because it's a leaf node. And so it will not add anything to my stack here or my fringe. And so the next element in my stack is 5. So on the next iteration of this while loop, I will be removing 5 and then printing out its value. And so, oh, I think I also forgot to cross out 1 when I first did that. So that would have been crossed out in the very beginning. Sorry about that. So yeah, now I've added 5 as the last element. And since 5 does not have any children, it is a leaf node. So these values are null. I'm not actually going to add anything to my fringe. And so this is the final traversal for the stack. We see that it's a little different. So 1734295 is a little different from the earlier one. Oh, I erased that one, but that should have been, so for a queue, it should have been 1275934. And for the stack, we found that it's 1734295. And these differences mainly occur because of the way that we're adding to the queue and the stack. So the queue is first in, first out, and a stack is last in, first out. So those are the main things I would keep in mind as you're doing problems like this. Cool. So that is the end of this walkthrough. Hopefully you found that useful. And if you have any questions, make sure to reach out to your mentor. Cool.